All right, we are now recording. Let's go from current slide. Okay, any questions or comments from the field trip or questions about what we've been doing so far? Let's just go over quickly. It's now about a little after 4:30.
4:31.
4:31. We will go until 5:15. And at 5:15, we stop and have the test on chapter 20. Make sure that's right. Yeah, chapter 20, which we finished last time. All right. So any questions on, especially on 20? If you don't have your formula and equation sheet ready, you can be working on that while we're doing this too, if you like. That's up to you. Okay. Now, the general section we're on are, let me go back one slide. I'll come back to this one. Weather producers, okay? And we did this slide last time and talked about the really big picture, what happens around the globe. Now we're going to talk about the next big picture, which is a little bit smaller than that one, and these are the air masses. Now, generally there are these masses of air, and here's Demetri. And did you say you did need the take-home test?
Yes, sir.
Okay. So what the air masses are these huge, horizontally, fairly uniform bodies of air that cover portions of the globe. When they say horizontally uniform, the moisture and temperature conditions nearly the same for the entire air mass covering this large area. Okay? There are four main types of these air masses. Those that are way up north over land. These are called continental polar, or way down south over land. Continental polar. Then you have the way up north or way down south over the sea, over ocean. Those are the maritime polar, way up north or way down south. Then you have the air masses that are over the warmer areas. If they're over warmer land masses, they're called continental tropical. If they're over oceans, then they're maritime tropical. Now these dictate what we call the air mass weather. Okay? Rather strange term, but it's called. This is the weather conditions controlled by these air masses. Now, weather conditions remain the same over several days because these are big air masses. They generally move quite slowly. Okay? So your weather conditions will remain the same over the next several days. When you hear them making the predictions, they'll say, yes, in the weather today, we expect a high of 92 and the low of 74. And tomorrow we expect the same. And Friday is about the same. And on Saturday, it might be 91 and 73, or something like that. You're typically under air mass weather. Not changing very much day to day to day. Now, I don't know exactly what we're under today, but it was a lot like it was yesterday. Hot, humid, and then it rained a lot in the evening. Okay? And it looks like it might do the same, judging from those clouds that we saw coming in. So, the weather changes when a newer air mass moves in or when the air mass acquires local conditions. Okay, now what does that mean? Okay, now this time of year, I don't notice many continental polar or maritime polar coming down to greet us. They just don't happen. Mostly what we get are continental tropical or maritime tropical. The continental tropical are going to be mostly dry, hot, and the maritime tropical, wet and hot, okay? It's just generally pretty hot. Now, I remember one Labor Day, it was a year or two after we were married, back in 86, 87, something like that, and it was cold on Labor Day. Well, we went to Georgia to see my mom, and my dad was still alive then, and it was so cold my wife had to go buy a sweater. It was just unusual. So that may have been a continental polar that came down and cooled things off some. It wasn't that cold, but that's when the weather changes, when some new air mass moves in, or when that current air mass either warms or cools to meet the local conditions. And then you'll have a little bit of change. Now here's the slideshow's introduction to this. The one in the book is much better, figure 23.6. Much more descriptive, I think. But it's saying the same thing. If we have those air masses coming down from Canada, those are continental polars, okay? And we do have them, mostly in the wintertime, okay? And in the wintertime, when you hear the polar Arctic vortex or something like that coming in, you know you've got cold weather coming, and it's probably going to last for a few days, okay? That's your continental polar. Usually quite dry and very cold, okay? Now, coming in from the northwest or from the northeast, those could be maritime polar, coming off the northwestern Pacific or northwestern Atlantic. Those are both maritime polar. They will be cold, but they tend to have moisture associated with them. Usually the moisture will keep the temperature from getting quite as low. When they're cold and dry, like the continental polar, you'll get frigid temperatures there. Okay, those that come up from the southern Pacific, southwestern Pacific, those are maritime tropical, or coming off the southeastern part of the Atlantic or the Gulf of Mexico, those are maritime tropical. This is what we get a whole lot. I wouldn't be at all surprised if we're not under the influence of the maritime tropical right now. All those clouds, all that humidity, but still it's warm, sticky, fairly unpleasant temperatures out. Hot and humid. That's usually maritime tropical coming up from the Gulf of Mexico. Okay? We don't get too much the maritime tropical coming off the Atlantic. We do sometimes, but not often, because generally our weather patterns move west to east because we're in the temperate region. And so we don't usually get those coming there. But we do get them coming out of the Gulf of Mexico because they come up from the Gulf and then the prevailing westerlies blow them right over us. Okay. The one in the book shows a little bit bigger masses. These are awfully small looking masses here. Okay. This is one reason I wish I had the newer slide set. I may get it soon. All right, so those are the big masses of air. Now, when they come in and bump into each other, say the maritime tropical that we're under right now, if that is what we're under, which I'm guessing it is, if now we do get a continental polar coming in, that's going to create some problems. The weather fronts are the boundaries between these air masses. They're usually at different temperatures and quite often at different moisture regimes. Within an air mass, everything's pretty uniform. But when a new one comes in, the boundaries, you can have very different changes. Okay? Now, let's say in the next few days, in fact, I think my wife said they were calling for either this coming weekend or early next week that we're actually supposed to get some pretty cool weather. So it may be that we've got one of these weather fronts coming in. Dante's here. Okay. And by the way, let me, while I'm thinking of it, mark the lab. I'm going to call this Lab 7. If you see that on the grade sheet, that meant you went to the planetarium. Okay, Matthew was there, Dante was there, Ty was there, Demetrius was there, and Destiny was there, Justin was there, Demetrius was there. Good crowd there. Ishmael was there. Darren was there. Zachary was there. Sarah was there. DeAndre was there. And Chris was there. Okay. And by the way, Max wasn't. I think he's the only regular attender that wasn't there. That was really good of y'all to be there. Okay. So, if that continental polar does make its way down, it won't be very cold by the time it gets here, but if it does come down, advancing on the maritime tropical that's on top of us right now, that will be a cold front moving in. Because the cold air mass moves into and displaces the warmer air mass. Now, where's the warmer air mass going to go? Up, because the colder air is denser, the warmer air is less dense. Why is that? Why is that the case? The cooler temperatures, the air molecules don't move as fast, they don't bump into each other as hard, and they tend to get closer together. The more temperature, the more motion, the more movement, and they tend to bump into each other and spread out and get less dense. So the warmer air is less dense, the cooler air is more dense, so the colder air mass moves into and displaces the warmer air mass and moves it upward. The moist rising air is cooled, that warm air that was near the surface, now lifted up, is cooled, and that leads to large cumulus clouds, thunder clouds, and that is our unstable situation. If you remember that from the early part of the chapter that we did last time, that gives us that unstable situation. The rising air is cooled and it is less dense, and it just keeps on rising, but the more it rises, the more it cools, and all that moisture that's in it gets wanting to come out. Large cumulus and thunder clouds. Now, let's say that does happen. A continental polar air mass does come in. Ahead of that, and we'll talk about this in a little bit, you'll probably get some thunderstorms, those thunder clouds, okay? Now, if that cooler air mass comes and settles in for a while, then that becomes dominant. But then if another tropical maritime comes up to take its place, then you have a warm front. Because the warmer air is now moving in on the cooler air, the warm air mass advances over the cooler air mass just like before. Now, in this case, and let's get a graphic up here, I think that will make it be a little easier to see. This is not the right graphic, but while we're on it, we'll do it. They got these out of order somewhat. Now, you'll see one kind of like this in your text on page 580, but it's more of a manufactured one than one like this. This has a lot more data on it. Now, just to let you know, what the lines that you see here are what we call isobars. Bars mean barometric pressure, iso meaning equal. So these lines here all are at equal barometric pressure, okay? Each one of these lines is at equal barometric pressure. Now, here is your high pressure center. The lines going around this gets lower pressure as you go away from it. Here's another high pressure. Here's another high pressure. Okay? Not too much low pressure on the west coast. A lot of high pressure in there. However, and here's one over here, over probably Ontario, Canada there. There's another high there. Okay? But up here in the northeast, there's a low pressure. Now, one thing you might notice here, this is always the case, but it's important here, there's a lot more circles around the low pressure. That means it's a very low pressure area there. very low pressure. The isobars are close together. And where the isobars are close together, you get a large wind gradient. Okay, it's a pressure gradient, and that makes the wind very strong. This is what they call a nor'easter. Those come in, the northeastern part of the U.S., come down from Canada. They're usually cold, they're usually wet, and they can be pretty violent. And where these isobars are close together, that is indicating the wind is very, very strong, extraordinarily strong. Okay? You can have a lot of damage coming out of that. If that low pressure were down here, we'd call it a tropical depression. Okay? And you know what they's called. Ask the people in North and South Carolina. That was a hurricane, but still, even when it was a tropical depression, it dumped rain and dumped rain and dumped rain with a fair amount of wind too. So that's what you expect out of a low. Here's another smaller low here. Now here's the deal about these pressure areas. The circulation of air is similar. In a low pressure area, it goes counterclockwise in the northern hemisphere. In a high pressure area, the flow is clockwise. That's because of the I just went blank on the name of the effect. It'll come to me in a while. Okay. I keep wanting to say Bernoulli. It's not Bernoulli. It's another name that's somewhat similar to that, but that's not it. Ah, here they come. Or he comes. I thought there was more than one. Justin's back. All right, good deal. Okay. Now, these are your weather makers. Because the airflow around the low is counterclockwise, that produces air that's being pulled up from the south, makes for a warm front that you see coming there. The air coming from the north, it makes for a cold front. So you have a warm front on this side of the low, a cold front on that side. Same thing here. There's a low pressure, counterclockwise air flowed, and therefore it's a cold front coming down here. This high, of course, is doing clockwise flow. So over here, it's a cold front because it's bringing down maritime polar air and bringing it down, so that's a cold front. But over here, where it's pulling it up, that's a warm front coming in on this side. So you can have these fronts, they cover large areas. Now, what I don't understand exactly is what the driving force is here. Yeah, I do. Here's a high pressure area, clockwise flow, it dominates over the low pressure. That's a pretty weak load sitting over northeast Georgia there. So that's what's happening. So this is an indicator of the fronts, okay? There are other fronts. Okay, let's go. The warm front, we're going to see some of this talked about in a later slide. A stationary front, or when the forces influences the warm and the cold air masses become balanced and nothing happens. Now, unfortunately, that kind of happened in North and South Carolina, okay? After the hurricane came in, which was a strong low pressure, it lost strength and hit the normal airflow that was coming from the west, and they just sort of collided there, but neither one of them was strong enough to push the other one out, so it sat there, and they just had rain day after day after day, okay? Now, I heard on the news this morning that South Carolina, some of their rivers are still rising, even though the hurricane came ashore more than a week ago. The water levels are still rising, okay? So stationary fronts sometimes will just sit there on top of you. And that could be what we're under right now, because today was just like yesterday, and we got rain yesterday. It looks like we're going to get more rain. We got a little bit on the way home, but nothing like we had yesterday. But it still could happen this evening. Okay? Here's the picture that I was looking for. This is the cold air mass coming in, the cold front, and it's basically bulldozing over the warm front. This is the warm air mass that was here. forcing it up here, and we're going to see a better picture of what happens there. Here's the top view. This is the side view. Here's the top view. It just comes in and forces the warm air to jump up. Because it's such a steep climb here, the warm air goes up very quickly, cools off very quickly, and produces a lot of unstable weather. Okay? Let's see if we can get another picture of that. I think there was to be one there, but I'm not seeing it. It looks like we're missing two. Here we go. Here's the cold air mass coming in, a lot like the other one we saw. Warm air, warm moist air here. This forces up the warm moist air very quickly, and look at that cumulus cloud. I bet you've seen some. In fact, I think I noticed one driving here, but there wasn't much talking going on, and that AC system was really loud, the fans and stuff, so it was hard to talk there. But if you look out and see these tall, big, booming clouds like this that go up and sometimes have an anvil on top, that's a cumulus cloud. That's a weather maker. That's a rainmaker. Okay? And you see, it's because this warm, moist air is getting forced up by the cold air mass, and as it goes up, it cools very quickly, and then you get the moisture dropping out of it. Now, remember when we were talking earlier, if this was down in the tropics, then the moisture here is condensing around the condensation nuclei, and the droplets are getting bigger and bigger and bigger, and those rain droplets are falling. Okay? In the temperate region where we are, that's going so far up there, that moisture actually becomes ice. Okay? It becomes ice crystals. They become your condensation nuclei. The water droplets fall around those, and as they fall, they melt and become rain. And that's why sometimes those raindrops, even in the summertime, will feel so cold, because probably 15, 30 minutes ago, they were, maybe not that long, they were ice crystals, okay? So that's why the rain will sometimes cool it off. Last night when that last storm came through, I think the temperature dropped by 5 or 10 degrees. I mean, it was just so cold. Some of those raindrops had been ice crystals. Okay? So that's what is happening in the cold front moving in, moving the warm air up. That's when you have very unstable conditions. You can get severe thunderstorms out of those babies. Okay? Now, notice how tall those are. Up to 15 kilometers, that cumulus cloud. When the cold front bulldozes its way, forces that warm air up, and you get the big cumulus clouds going way, way up there. That's a huge temperature gradient there. Okay? When the warm air is advancing on the cold air, it sort of climbs gently up that cold air. You know, still the warm air don't go on top, but it's forcing the cold air back slowly. Well, look at these cumulus clouds. These are cumulus clouds too, barely 5 kilometers tall. Less than that, more like 4. The other was 15. So these are going to produce rain, but it won't be severe thunderstorms. And I'm kind of thinking, if we had been colder before today, which we weren't, I would have sworn that this was more like that, because I didn't hear much thunder. There wasn't much thunder with the storms yesterday. I didn't hear it, but I don't hear well, so I don't know. So anyway, you get rain, but it's usually gentler rain, generally without as much thunder and lightning. So it's not as bad a storms as what you get. I like this kind of rain. I don't like the thunderstorms. Okay. But there's warm air. These fronts, quite often, both of them, even stationary fronts, can be where rain occurs. Not always, but they can be. Here's a case where they would not be. If that was a tropical continental or continental tropical air mass coming in, usually that's dry, hot air, okay? And it moves over the cold. It'll warm you up, but it won't produce much rain, okay? So you see all these factors come into play. Any questions on that? Okay? Now, let's go back to this picture. Okay? Now, that's not going to show it at all. One more or two more back. Whoops. Yeah. Oh, I'm going the wrong way. Sorry. Yeah. When you do have this coming in, maritime tropical here in the southeast, coming in off the Atlantic, that is almost always related, though it may not always be a cyclone, it is related to it. This is when you get your tropical waves coming in. This is tropical, maritime tropical, really coming from the tropics here because they're prevailing easterly direction. And when you have those coming in, you can have these tropical waves approaching. So let's go back and see what they mean by tropical waves. Okay, waves and cyclones. This, by the way, is advanced to, and in your text, there's a great picture, figure 23.7, satellite photograph showing the result of a polar air mass moving southeast over the southern United States. You see Florida there, you see Cuba, you see the Gulf of Mexico, you see the southeastern Atlantic, southeast U.S. coast off the Atlantic. Here we have a continental polar air mass coming in. And here's the deal here, folks. This is coming from the northwest, off of Canada, off of the northern U.S., dry, cooler air, and warm, moist air was sitting here, and that's why you have the front here. Those could be some really severe thunderstorms along there. The bright white, okay? And then, if it advances, this is your cold front right here. As it advances and moves through, the temperatures will drop like crazy, okay? And it'll get much drier. So you expect to have severe weather on the front, and then after the front, the temperatures drop, okay? We don't have much of that in the summertime. We do in the spring and sometimes in the fall. But that line that you see here, that's down in the Gulf of Mexico. If that would have been up here, I almost guarantee you could have had some severe thunderstorms, possibly even tornadoes ahead of that front, okay? Because that is pretty major. Happens more in the spring than it does other times of year. It can happen some in the fall, but more in the spring. That's when you still get those very cold air masses coming down. All right, pretty good picture there. And then your diagram on figure 23.8 that I referred before was more like the actual weather map that they showed here, but it's a lot more illustrative. It shows the high pressure, and it shows the barometric isobars around it, low pressure with the isobars around that, another high pressure in the middle of sort of a weak one, and another low, and two lows have lines fairly close together, meaning they could create quite a bit of wind. Just more of a textural type. So let's move on. And before we leave weather fronts to get the waves and cyclones, there is a Science and Society at the top of page 581 that's pretty appropriate. It's called Urban Heat Islands. Okay? Have you ever heard the term? Urban Heat Islands. Okay? This is just a really minor example of it, but it certainly is. During the second mini-term, I will be teaching the Physical Science 2 class. but it won't start until 3:15 because automotive students take it and they don't get out of their class until 3, and then they come over and take this at 3:15 on Tuesday and Thursday. Second midterm I'll be teaching that. And so I don't get to drive home until about 7:45 rather than 5:45 or 6 o'clock. So I'll be driving, and especially later in the fall, it gets pretty chilly. Okay? Not super cold yet, but cold. Okay? I will leave here, Bessemer, okay, and go out to the car, and let's say it's 50 degrees on my thermometer in my vehicle. Okay, 50 degrees. I get on the interstate and start heading northeast. Now I'm not going super far north, but I am going north. I am going east, not super far east either. Well, if you think about it, north should be getting cooler, and east, the sun went down a little bit earlier, not much, just a few minutes earlier. So they've had darkness longer, the sun hasn't been radiating on the earth as long. So by all counts, and it's getting later at night too, right? Because as I drive, time is passing. So by all logic, it should be getting cooler as I drive. It was 50 degrees when I left here, and as I drive north and east later into the evening, it does maybe drop 8 degrees somewhere around Fairfield or somewhere there. But then, when I get toward Inslee, it usually starts rising. And I get closer and closer to Birmingham, even though I'm going northeast. Later at night, you know, everything should be getting cooler, it gets warmer. Okay? Sometimes by as much as 4 to 5 degrees. That's the heat island effect. Okay? That's what they're talking about in this little blurb here. It's a very short one, but it has several questions. If you wanted to do a paper topic on one of those, you certainly could. Speaking of which, this obviously one of my best classes ever, right? And how many research papers have been turned in? Oh. Yeah, okay.
Last time I checked, it was 5.
Okay. 1, 2, 3, 4, 5. Yes. 5 have been turned in out of 14 students. We did have more, but we dropped a few. That's just barely a third. And how many weeks do we have left?
2.
2.5 weeks. That's all, folks. Got to get them in. You can still get that bonus point if you get them in the month of September, but October, 0 bonus points. Okay? So try to get those in. All right. Now, finally, let's turn the page to waves and cyclones. These are other weather makers. Okay? Now, some of the graphics here I find not all that much enlightening. Okay? But here's the mechanism they're talking about. What a wave or a cyclone is a bulge or a wave. Bulges or waves often form between oppositely moving air masses. Okay? Remember we had the illustration, the cold air pushing the warm air up and out, or the warm air sliding over the top of the cold air. Well, sometimes when those are happening, you get what they call bulges or waves, where it's an area where you have instability, okay? And that's what creates that bulge and wave there, okay? The overriding uplifted cold air produces a low pressure area, okay? Overriding uplifted cold air produces a low pressure area, okay? Further cold front motion leads to an occluded front, and that could lead to a cyclonic storm. What do we mean by that? Tornado. A cyclonic storm may not be, it could be a severe thunderstorm, but it could be a tornado. Now, this is where the graphic almost doesn't make any sense, okay? It does to someone who knows what they're talking about, but really I think it's pretty poor. Number one, why in the world is the warm air down beneath the cold air? The cold air is denser, the warm air is less dense. They should be reversed. They're showing it the other way. That's really unstable, very unstable. So what happens here, the warm air, being less dense, is sucked up into the cold, and this produces, if it's moving in this direction, the cold front. If it's moving in that direction, it's a warm front. Okay? Because the warm air is under here pushing this way, cold air is pushing this way. So one or the other is going to win here. It's not really clear who wins. That's the bulge they're talking about. It's a pressure bulge.
So is it like it's water, right?
What's that?
Is it like over water too?
Yeah, it can happen over water, and then you have what they call water spouts.
It's like when you swim in and you get out and shivering. So I don't know. It's
Yeah. Yeah, and sometimes you'll feel them in the thing. You'll feel it feels like the water is swirling around you, and that's because it's doing the same thing. What's that?
I said that would be scary. You know, just in the water, and then a water sprout, and you get rid of it.
That can be really disorienting too. Okay, so let's say that this the warm front moving this way, the low pressure, cold front would have this so backwards. If it looks like it's winning coming this way, so here we have a low pressure area. So the air tends to, because it's low pressure, it swirls around and tries to make up the pressure difference. Okay? And when that happens, you get what they call an occluded front. And again, this graphic really doesn't explain much at all to me, but that I can see what they're trying to say. The graphic doesn't do a great job. And what you have then is a low pressure area from that. You see the motion starts in here and continues building until you wind up with a low pressure. That is a cyclonic activity. And that could be a tornado. Okay? It could easily be a tornado. So, this is a cyclonic storm. What is a cyclone? It's a low pressure area with inflowing, upwardly forced winds. Why upwardly forced? It's low pressure. So the winds are forced upward. The unstable situation. Okay? The circulation, there it is, Coriolis effect. I knew it was going to show up here. I couldn't think of that word earlier. Coriolis effect. When when motion is happening up or down above a spinning planet, okay, and remember we're spinning pretty rapidly. If you saw that graphic in the slideshow of the moon going around the Earth, and you saw the Earth is spinning pretty fast, okay? And if you have movement either up or down with a spinning globe, you create the Coriolis effect. You don't have straight up and down motion, you have twisting motion because of the spin of the Earth. Circulation pattern is caused by the Coriolis effect, and that would be a good paper topic. Who was Coriolis, or what was that effect, and how did he illustrate it, or whatever. Okay? Now, if you had that other situation, I mentioned the high pressure area, that's anticyclone. That's in the northern hemisphere, the cyclones are counterclockwise flow, just like hurricanes are and tornadoes are. In the northern hemisphere, the high pressure areas are clockwise flow. Okay? The air sinks, is warm, relative humidity actually is lowered. You're not going to get severe weather out of that. Ever, as far as I know. But of course, you go into the southern hemisphere and everything's reversed. Okay? The rising air causes clockwise flow, which is your cyclonic effect in the southern hemisphere, and your falling air causes the counterclockwise flow in the southern hemisphere, which is your anticyclone, which you don't have a situation. Okay? Now, this is an interesting graphic, not explained too well, but it's an interesting graphic. These show some of the common cyclonic paths that we typically have in the U.S. Okay? And I'll bring your attention to this one right here. You see this one? That is the one that was followed back in, I keep forgetting the dates, April 20th. Yeah, the big tornado day. You wrote your paper on it. Right?
It was following that path from April 25th to the 28th.
Yeah, and look at this. That was exactly where it came from. Central Mississippi, only the path was like this that day. It went from southern Alabama to northern Alabama. Just a whole band going across here. And later, it continued on up here. Lost strength like crazy, but we caught the brunt of it right there.
Yeah, we caught the whole work.
Yeah, I mean,
in Tuscaloosa, Fultondale, Birmingham.
yeah. And there were some places further north that, I mean, whole towns were just wiped out.
Yeah,
some
Concord.
further south. Yeah. It was just, wasn't there a town called Paul something, or I want to say Hamilton, that's not it, but yeah, but some town that just was wiped out. You
From
could
the
just,
tornadoes in April?
yeah, the April, of, what was it, 70? No, 90, no, 2011, 2011, yeah, okay. Now, there have been others. My wife was living in Huntsville when one went up that way, and they were really strong there. There were a bunch of them. Occasionally they always follow a path way down south. The ones you hear people talk about a lot. Oh, and by the way, Dallas had one, Dallas, Texas, a few years on one side or the other than the ones that came through here. Missouri has had several. In fact, the next year or that same year, Missouri got whammed the same way that we did, maybe not quite as bad. So that's cool. Okay, there's Missouri. Or this one, you know. So there are these patterns that go across, and they can be vicious. Okay. We will stop there and pick up next time with major storms.
5:13 now.
Yeah, I think that's a good stopping place. We don't really have time to start. Major storm's a good break point. Does anyone need a break? We haven't been going very long, but restroom break, bladder break, whatever. If not, if you want to go on and get started on this test, you can. And you can use formula and equation sheets, scratch paper. You won't need a calculator, but you can use it if it makes you feel good.
I'm going to have my drink, and I'm packing my gear up.
Okay. So let's talk about what happens on Thursday. On Thursday, we continue in chapter 23. Okay? The last 2 hours, we got to make up the lab that would have been today that was from chapter 20. And that's, it's actually going to be, goodness gracious, I'm going blank on it. Topographic maps, okay? That's what we'll be doing the last 2 hours. So we'll go for 2.5 hours. We'll continue in chapter 23. We may actually finish 23. If we do, we'll go on and start 24, okay? But then the last 2 hours, we will actually hit the, do the lab that we would have been doing today. But we went to the planetarium today. So, then on Tuesday of next week, once we finish this chapter, I'll start calling Terry Tracy to see when he can take us. Because that's going to be our lab for chapter 23, the trip to the Weather Center. I don't have anything else I can do as a lab. So that's going to be our lab for that.
Can you possibly get them to let us, mostly be on air? Hi, so I'm from Belsman, y'all, and this is the news.
God.
Okay.
Yeah,
That's
for the love
enough.
of God.
Okay.
Yes,
You will get to
yes,
stand in
love,
front of the
yes.
green screen and watch yourself, but you won't be on air.
I'm like, yeah, so my name is Zachary, and I'm seeing a folks named Matt Train, and I'm from Bessemer.
Okay. Green room. Okay. All right. So I'll start planning for the field trip for the weather. Depending on when that is, then that'll determine when we have our test on chapter 23. We'll continue with chapter 24. When we finish 24, we do have a lab for that one, and then we'll have a test on that. That'll get us awfully close to the end of the term. Okay? So, y'all ready for the test, or some of you not going to take it? Ready?
I'm ready.
Okay.
You know, I was here and get
What's that? Okay. All right. And this is test 7. This is on shaping the Earth's surface. Okay, the last chapter we did was 423, chapter 20. Okay.
I'll get back in.
Okay, that'll be fine. All right. Those who are still here, who are planning to take the test. Keep one page out.
Hey, you different colors, color system.
Take it.
Yes, sir.
Take it. You gonna take it? Yeah, when you take it. That's
The top school bag and the school to be back up.
the dark side stayed with us here, the light side left. Okay. They were a bunch of lightweights.
That's like,
Okay.
that's like,
That was good. That was good.
the dark
You know, you're still
side
on
stayed
recording.
late, but the light side left.
What's that?
The white
Still recording.
Yeah, I should have recorded that. Okay.
He said the light side.
That was good.
All right.